Thanks everyone for joining. My name is Barry Gotch. I'm the chair of the Hollywood SMPTE chapter. And I have to give a great shout out to my team at Hollywood SMPTE, who's really put a lot of effort to get this webinar together for all of us. The idea behind this webinar was that I'm just being out in the world and listening to what people are talking about at events and trade shows. The topic of NDI came up very often. I was like, oh, I need to learn about this. And what's the best way to learn about this? By challenging yourself and putting together a webinar and bringing in experts about the topic. So we're going to have 3 presenters for the webinar. We're going to start with Will from NDI, then we're going to go to Mike from AJA, and we're going to finish with Jorge from ASG, and then we'll have a question period at the end. And so the questions will go straight into the chat, please, and then we'll do that. And we'll try to wrap this up in a nice, tidy hour so we can do this essentially as a lunch and learn session. So with that being said, I'm going to stop sharing. And if you want to go ahead, Will, and take over for your part of the presentation.
Certainly. Let me know if you see that screen share there.
I do.
All right. Excellent. Thank you, Barry, for the introduction. And I want to extend my thanks for everyone allowing some time here today. And yeah, my name is Will Waters. I work with NDI. I work in our product management team, heading that up, and work with a great team really putting all this stuff together. But I've been invited by Barry to really talk about what NDI is and kind of where it came from and why does it matter. So I think that everyone on the call probably knows and understands that we've been in a transition to IP, and I don't think it used to be that we had to have a big debate about that, but I think that today we can all agree that that transition to IP is well underway. We even have remote productions. The pandemic changed a lot of things about how we do production and how we move and just interact with audio, video, metadata, and pretty much everything that we need to do for productions. Ultimately, that's not just influencing the broadcast space, but it's really across the entire video production spectrum, where we even have blending like what we're doing today right now with a virtual meeting room application in Zoom, and we're all interconnecting and utilizing video to really move across and have everything connected in that way. So NDI is a way to move, of course, audio and video, metadata, control, a lot of things across the network. But this all comes into what IP can really do for us. And any type of need for IP, and I know many of you have been following the transition, the discussions, the JTNM roadmap, the efforts from the VSF forums and AMWA, along with the SMPTE standards that ultimately arrived at 2110. So any IP video standard must have low latency video optimizations, but really to produce on it, you need to have things easily discoverable. You need to have adoption across multiple manufacturers and multiple products. And of course, what's really important is there has to be a plan for long-term development so that we can evolve and move forward in the ways that we need to. Let me just handle, I guess, what's usually the elephant in the room is just like, well, with 2110 and the ongoing work and everything there, why do we need to even talk about something like NDI? And what I'd like to present to you all today is that really NDI is focusing on solving a different problem than the standards of and the amazing work that's happened in SMPTE 2110. Mainly circling around looking at things from a software first standpoint, but ultimately, what I'd like everyone to come away with today is that the real standard that any of us would talk about is that Ethernet cable, that packetized flow of being able to move data from one place to another. It really allows it to be agnostic across whatever protocols, and many of these protocols can operate in tandem together to really be able to create the workflows and the needs that are necessary so that we can really create more storytelling in the marketplace. And that's ultimately what we're looking to do. But the history and the quick history here of NDI is that actually it has a long time in development. If any of you know the company NewTek, that's where NDI came from. I spent a lot of time there, as well as one of my other co-panelists, Jorge. we were working on basically what we called software-driven live production, which was centralized around taking a computer, having software, being able to do video production. And for those of you who are around, all that stems originally from that idea of the video toaster back in the 90s. But anyway, moving into the world of IP and the discussions that were being had around 2015, NewTek had a situation where they needed to get more inputs into a computer, and utilizing the baseband flows of SDI, and then of course even things like SMPTE 2022 was really difficult to be able to work. And but NewTek had some technology to be able to really take that and push that across the network. And we also looked at what was going on and realized that while the great and amazing work was happening with SMPTE 2110 in the project, that was going to be unattainable for many folks that were in the corporate space or that were needing to do direct to OTT delivery or having to have niche content to be able to get out just for the sheer cost. But they still needed some of the same needs to be able to have more sources in more places, and of course do that all in content delivery with an on-demand standpoint, and then stay within some type of budget. So ultimately, NDI was born. It was released to IBC in 2015, and the explosion and the rocket ship that has been that since, and especially fueled by what happened during the pandemic, has really led to an explosion of adoption and workflows that allows for many different licenses that have been delivered out. Literally millions of users utilizing the tools. And in some cases, you could really argue that it's a preferred standard for some production environments, and it includes all of that with audio, video, metadata, and the like. Now, we need to be able to work on existing networks, and that's what's really one of the big needs and one of the big goals of what NDI is and why it's important. Most facilities, especially in 2015, but this is still true today, had a 1 gig infrastructure. And the cost of getting 100 gig interfaces, while it could be useful and available with very top tier broadcasting and facilities, it was not going to be suitable for direct to digital adoption or productions that were on very limited budgets. So they needed to use what they had. So a standard that utilized compressed methods were really going to be necessary, but not only that, it had to be easy to set up, to configure. There needed to be auto discovery inclusions with it. We need to be able to find sources by names and not have to remember IP addresses. And then, of course, interoperability is the most important, being that you take the best device from one vendor, connect it to a device from another vendor. And of course, between those two standards, you have all the points of not just video and audio, but control, the metadata, sidecars, and any other formats or information you need to put through there. And ultimately, that's really what NDI focused on. And before NDI, those, let's call them mid-tier productions, needed to use multiple signaling paths, whether that was HDMI or SDI. And HDMI started to grow in that particular zone and everywhere as well, but a different path for audio and, of course, power. NDI really brought all that together to be able to create an ecosystem that would allow for single streams for audio, video, metadata control existing within that network interface. And as it grew, so it started as a LAN only protocol in 2015. And then we delivered some adoptions, some expansions to the protocol that we got back from the field, from use cases that would allow for both WAN and LAN access. But the one big thing, and I'll get into the real technical details here in a moment, but it needed to be cost efficient on existing tech. And that was not just with the networking interface, but that also came into things like, well, what FPGA chipsets were available on cameras and manufacturing, because we couldn't wait for 2 or 3 years to develop entirely new internal structures, say for cameras. We needed to figure out how to use what was available and the encoding methodology and functions that were available at the time. So ultimately, though, NDI is more than a transport. Every piece of NDI equipment can utilize the network for video, audio, and data. And you can actually have NDI components that are only looking, for instance, at tally information. Or you can utilize NDI to deliver a key and fill signal with the alpha embedded into a single stream. One of the benefits as well is that every connection is bidirectional. And that's unique in that when the source knows how it's being used downstream, that creates new ways to think about your workflows. When you don't need a device because it's not in use, you can, of course, there are efficiencies from just a ecosystem standpoint, but it also, you can tailor and adjust the source device based on how it's being used and adapt that accordingly because of that bidirectional nature of how things are being used. And of course, we are a compressed standard. We at NDI have never looked at the fact that, if you need uncompressed, there are really amazing ways, and the SMPTE group has done a truly amazing job of working out how to pass uncompressed video. But we were looking at solving a different problem to really allow for that vast and high adoption that only compressed formats would really allow us to realize. Of course, there's more, again, than those transports. There's metadata that needs to be working with devices, whether that's things like a triggering, or it could be PTZ control, where your receiving device has the ability to adjust your camera by both the mechanics as well as the sensor capabilities. The NDI allows for timing without central clocks. And this is really important, I think, and maybe one of my co-panelists will be able to talk about this in cloud deployments, where you don't have hardware-based clocks that you can work in different productions. But again, more than just a transport, the NDI ecosystem includes a full SDK that ultimately allowed software developers to be able to create tools and products quickly and easily, expanding out workflows in ways that really, if you're based solely or focused solely on getting hardware to market, you just don't have that time in a fast changing world such as we're in today. We also have plugins that expand the workflows in the post-edit world, such as with Adobe Premiere and Final Cut Pro X, along with tools that really allow anyone to start working with NDI as soon as they get the download, whether that's delivering and looking and monitoring NDI sources, or it's connecting with audio interfaces through VST plugins or directly into drivers. There's really powerful set of tools that come with that. So it's a full package that goes in a full ecosystem instead of just a transport. Now, and I know I have to move quickly here because we only have so much time, but there are some technical details that I think are always handy. And I usually find with a SMPTE group, they're very much looking at what some of those technical details are. And a lot of that centers around the codec. NDI actually comprises multiple codecs, but it's all within a single ecosystem. At the launch of NDI, we had something that we called, it's now called NDI high bandwidth, but this was the original delivery and the compression mechanism that went along with NDI. It was a software-based IP codec. We currently sit that and call that an NDI 5.5. Again, it's resolution and frame independent though, and that it has support for video, key fills, tally, custom metadata, and even if the developer would like to, attaching to precision timestamps. And what's important here is this codec has availability on Windows, Macs, Linux, iOS, Android, and even ARM platforms so that there can be interoperability. But this high bandwidth codec, this is something that we call Speed HQ, like really into the technical weeds, but it's an incredibly efficient encoding. One of our goals when we originally launched this to market was that the encoding really needed to be no more impactful on the CPU than, say, utilizing a standard SDI capture card. So the efficient encoding we clocked in the lab, for utilizing 8K at 320 frames per second or 4K at 1,000. This is all on your modern CPU architecture that you can really buy commodity off the shelf just about anywhere. And then the one frame of effective latency really is how that can be adjusted or how that performs in a lab environment. It is built around a DCT 8x8 compression, and that's similar to things I'm sure that you know, and that gives a lot of capabilities to be able to push a lot of video around, again, on that single gigabit. And if we expand to 10 gigabit, 25 gigabit, 100 gigabit, we certainly get the efficiencies to go along with that. But as we moved forward, we did find that we needed to have a more efficient mode. I mentioned before that it's not just about moving things around, but it's also the cost of developing within products. And we looked around and we saw that many cameras had the ability to deliver H.264 compression streams right within the products themselves. So we worked with a few of those manufacturers and we delivered what we call the high efficiency variation of NDI. And what's amazing about this, it has all of the workflow capabilities of bidirectional communication, being able to be discovered and represented on the network, but also playing to bandwidth restricted environments, transmission across geography, and even in some cases, Wi-Fi capable. So that really has an even higher compressed methodology. And you can see on the screen, or we can review that later for time, but it really has a higher compression, but still operates within that same environment. But let's see, about 2 years ago now, we also saw a need to basically have a third variation in between this high bandwidth, still everything compression, but also the high efficiency mode. And so ultimately we had something that we came to market with what we call HX3. And this adds to those high efficiency features the ability to take H.264 or HEVC and have a higher bandwidth. It takes higher bandwidth, but it reduces the latency from, say, in a camera, from camera to output. And also, as part of that, we identified through our licensee partners that there was really a very present need to have actually a certification from the NDI team to be able to say, hey, this particular product operates in under these experiences. And so that's what HX3 is all about. It has a higher bandwidth than HX by itself, but these are all interoperable within the workflows so that producers and users and integrators can really choose the best that they need for their productions. Ultimately, discovery and registration is available throughout NDI. We have discovery services that operate both on the LAN or zero configuration that really just make it plug and play, utilizing MDNS responders and broadcasts. And there's various transmission methods that we have been able to deliver across time, depending on what we had for the feedback from the whole landscape. So reliable UDP is the preferred methodology of delivery today, although we still have single TCP sessions in unicast, and NDI does support multicast. So these have options depending on what the network environment is and what they need. And again, it's not just about the transport. We also have a full suite of tools that allow each and every one of you for free to be able to work and utilize and test and, let's say, validate whether or not the NDI for the workflow and the interaction that you may need are suitable for those things that are useful. This has been something that has been very powerful, such as Studio Monitor, being able to really view NDI streams around, being able to take screen capturing, and it's very handy for, say, esports and e-gaming because it works directly with, say, the GPU interface and delivering a transmission and handles frame rates adjustment on the fly. These are things that only occur with a software-based library, software-based environment, such as what we were dealing with NDI. And then, of course, the adoption of NDI is super important. And it's really our ecosystem and our community partners that make NDI what it is and to be able to be utilized for so many different workflows and use cases around the market. And with that, Barry, I am going to deliver it back over to you. Of course, more information can be found right on the NDI website at ndi.tv. But I think it would be really good to hear from my co-panelists on the practical applications, not just the theory that I've described today.
Yeah, thanks so much for that, Will. If you could turn off the screen sharing, great. And Mike, if you want to pick up the screen sharing and unmute yourself. So Mike, are you ready to go?
Yes, I am. Thanks, Barry.
Right. Yeah, and, of course.
Yeah. And Will, thanks so much for introducing NDI. It's going to be hard to follow that, but I will do my best to keep it interesting. Anyway, my name is Mike Bookey. I'm the product manager for IP products at AJA. So yeah, I'm looking at the next trends in the market and to help AJA build IP products that our customers need. What I've decided to do is put this into some little headers here, and the way I've split it up is to have some different conversation points. So the first one that we're going to go through is what makes NDI a desirable technology to use. Then we'll follow it up with how does NDI compare to other compressed and uncompressed formats. And then just a short statement about it being a compressed world. And at the end of that, we'll talk a little bit about what AJA is doing. So as Willow did present, NDI has become a leader in the mid-tier or the pro AV industry, and many companies have adopted the technology to build products. But what makes NDI a really desirable technology? NDI provides a high quality and low latency compression while providing frame accuracy. A workflow can remain native in NDI for its entirety from the camera to transmission. So NDI was also developed to utilize simple network infrastructures. The ability to use the network infrastructures like simple network switches and cables has provided customers the opportunity to try NDI products and often have found that there's minimal investment needed to enable a full NDI workflow instead of the traditional rip out and replace that we've always had to do with STI. So this has really provided a great opportunity to easily try NDI and integrate as was needed. NDI endpoints are also relatively cheap compared to their counterparts and have made high quality video capturing, editing, storing, and transmission attainable by many different tiers of users. So this goes from the simple YouTubers up to large call letter broadcasters. NDI has also been widely adopted across all major production segments. So this includes esports, live events, broadcast, post, and even on-set. So next, let's go on how NDI compares to compressed and uncompressed formats. As you probably all know, introducing compression into broadcast workflows has historically been met with obstacles, but the need to shove more signals down a limited pipe in order to get more cost-effective has led to a variety of options. NDI was designed to be easily implemented in endpoint products, either via software or embedded via ARM and FPGAs, and also Will went over a few other options. NDI also built in its own control architecture, which does set it aside from other compression formats, like MPEG-2, MPEG-4, HEVC, and J2K. Of course, down to AV does have a comparable technology and includes a control architecture, but at this time, NDI has the momentum in the market. So what about uncompressed formats? SDI has been the standard for quality, and perfect timing has always been a must. So the inevitable move to IP led to SMPTE 2022-6 and then SMPTE 2110 with redundancy via SMPTE 2022-7. But as Will said, the IP protocols came with overhead costs that really made them untouchable by the pro AV market. So this includes items such as purpose-built network switches to guarantee no packet drops at any egress, sync generators with SMPTE 2059 PTP, and then the orchestration systems to manage the complexity of NMOS, network fabrics, and endpoint programming. Of course, this quality has its place, but high price and complexity don't fit well into the pro AV market. So the reality is we have a world with multiple compressed options, and don't feel overwhelmed by this diagram. It's just to showcase a variety of compressed protocols and the complexity of implementing them. NDI is also used extensively by streaming platforms and broadcasters that store and distribute from server farms. With streaming platform deliveries blurring with traditional broadcasts, NDI now runs alongside other IP transportation protocols. Not only do they run alongside each other, but there are often calls to convert from one to the other. Where does AJA come into this? There are a huge number of single endpoint devices for many vendors. An area that customers we felt were underrepresented are high density products to facilitate larger environments. So we built our bridge products, which have been helpful for customers in both the Pro AV and the high-end broadcast world. The first product, which is up at the top there, is the Bridge NDI, which is a 16-channel NDI converter with multi-viewing. It provides the highest density NDI to and from SCI in a 1RU server. And finally, there's Bridge Live on the bottom. It's a powerful transcoder which can convert multiple individual signals at once to and from NDI. So this can go through a variety of standards such as SDI, SRT, MPEG, J2K, HEVC, and more. Both of these products fit well to provide the density and scalability our customers have been asking for. Thank you for your time, and I'll hand it back over to Barry.
Oh, thanks, Mike. Yeah, if you could stop the screen share for the moment. There we are. So Jorge, okay, so you're here to round out the meeting. Yeah. You're batting cleanup, so to speak.
Yeah.
Yeah. So yeah, please do go ahead and start your screen sharing, and we'll start the presentation, and then at the end we'll go for a Q&A. Thank you.
Perfect. Thank you. Thank you very much. And the idea of this presentation, obviously, there is a small amount of time where we can talk about NDI for hours and hours. But the idea is what or how we can present the use of NDI from a practical stand. So this is, as ASG, as system integrators, we have been working with NDI, I mean, for a long time, since the beginning. And one of the most interesting cases that I want to focus on is the use of NDI within the cloud infrastructure. The idea of start to bring live production to the cloud started to arise. But there was a very important obstacle, which is, okay, we can take signals to the cloud. That was not the problem. There were many, many ways on how that could be done, many transport mechanisms that can be utilized to take sources from on-prem to cloud. But what happens is, when all these signals come or arrive into the cloud, the same as with a typical control room, now I need to orchestrate all these sources. I need to send it to audio mixers, to video mixers, I need sources from graphic systems, all the different components that we know are needed for a production environment. And there was not an easy way to do it. And this is where NDI basically came the perfect tool to solve that problem. So with that, we started doing a lot of work on testing NDI within cloud environments. And at the time, it was immediately a major thing that was a big hit, is that NDI did not require multicasting. No, and for those who work in the cloud, they know that, multicasting, to utilize multicasting the same way that you do it in video environments that you do it on-prem, it is pretty much a no-no. So right off the bat, NDI was solving a big problem. It was solving a big problem. So we can take that one NDI stream that has arrived from on-prem and then distribute across multiple devices without any problem at all. The switcher can be consuming the stream, the audio mixer, we can be receiving NDI stream from the graphic systems. So NDI was the common denominator in order to share those video streams among all the devices. And of course, devices that were NDI enabled. But the interesting thing is just about everything within the software layer had already NDI implemented. So here we are seeing a typical, setup that we do where we have a vector switcher from BSRT. And obviously this is coming from, obviously we work with all the cloud providers, AWS, GCP, of course, and Azure. And in this case, what you are seeing here, this is the switcher in the cloud where all the streams getting into the switcher are NDI, control surface connected to IP. So the TD is switching this show exactly with the same latency pretty much, I don't want to say exactly, but extremely close to the same latency as if the equipment were on-prem. So the important thing here is that all these components that are required within a production environment, as I mentioned, switchers, audio mixers, graphic systems, playout servers, something very important, signal orchestration solutions. We know that it's not just simply about getting the signal, in this case, in the cloud, but in many cases, we need to start processing that signal. Do we want to shuffle the audio tracks? Do we want to do some color correction? Do we want to, for example, change the format of the signal coming into the cloud? All these requires different tools, which they are all talking to each other through NDI. So with that, why, let me see, there we go. So why NDI? And these are some very key points that in a way are very similar to what Mike and Will has already been talking, but flexibility is, why flexibility? NDI, I mean, is extremely simple to set up just about in any network. No, low latency is an absolute must, and NDI has the latency that you would expect if you were using SDI 2110, and that is an absolute must, because none of these would make any sense if latency within NDI was, I mean, 7, 8, 9 frames. We know that, I mean, NDI would have never grown to where it is today. High quality, it was always at the top. I mean, as Will mentioned, NDI uses DCT on an 8x8 block, and there are very important codecs using the same pattern, and is pretty much a standard in the industry. Cost effective means that you can deploy NDI because it's a primarily software first solution, with a lot of many software solutions in a relatively very low cost, all the way to very high-end systems. Scalability is another important factor, and especially for cloud is where this is a very important key point. When you try to receive I mean, almost uncompressed video to cloud, we know the bandwidth required for that makes it almost prohibitive. And in some solutions where that's the case, also the compute required within the cloud infrastructure to move that, it makes it extremely expensive. So that's where NDI, you can run, I mean, I'm not going to say very small instances for cloud deployment, but medium to medium high, and it's going to allow you to have a very high density number of streams without having to have a big infrastructure in order to do so. And the scalability, even within on-prem environments, there are, I mean, customers that are running NDI streams into the thousands. So this is not something that people are using 10, 20, 30 NDI streams. There are facilities that they are literally running NDI streams into the thousands. No, and this is something very important. Compatibility, as very well was explained by Will, because of the big ecosystem that has been created both on the hardware and software side, makes NDI fully compatible with everything else that basically carries NDI. The access to the SDK is extremely simple, so developers can maintain those libraries in a very simple way, ensuring that if you have any piece of software that is NDI capable, is going to work out with any other piece of software that is capable of moving NDI in their applications. For remote productions, like I was mentioning, especially within cloud ecosystems, NDI is king, and cloud loves NDI. And we are working in multiple projects at scale where the center core of how video is moved in the cloud, it goes, I mean, is basically everything around NDI. There are multiple vendors with multiple solutions, each one tackling different part of the productions, but the common denominator among all that is where NDI is the center on which streams are moved along all those devices. Easy to use. I mean, NDI, you can deploy an basic NDI testing environment literally in minutes. I mean, we do very high 2110 deployments as well, and obviously 2110 is fantastic and the capabilities are, I mean, incredible, but it does require, I think everybody that has done 2110 installations requires quite a lot of preparation and knowledge in order to deploy and maintain that infrastructure. And the idea with NDI is that it can be deployed pretty much just by connecting two devices on the same network, and there it is. You're going to see them and you can start using them. With this, I don't want to minimize. If you want to do something at scale, it does require preparation and understanding the topology of the network and the hardware being utilized. But if someone just never have heard of NDI and wants to use it, just by downloading NDI tools, within minutes, you can have NDI flowing in your existing network today. Security is very important because, again, NDI uses standard network protocols and encryptions, so it provides a secure solution for live production in the cloud and obviously on on-prem networks. And the adoption, as you all know, because both Will and Mike has mentioned this, it has been absolutely incredible. I mean, when I was at New Tech and the idea of NDI came to the table, even though we are all were wishing for the best, I don't think we ever imagined to the scale and the place where NDI is today. Has been incredible and magnificent ride. And to give an idea, even in my position at Grass Valley, working on AMP, NDI, it was a very, very important part of the equation. So even, I mean, within AMP, system orchestration, NDI was very, very much a very important part of that product as well. So this is nothing but just a small token of products that we work with, where NDI is very much at the center front and allows for easy compatibility between all these devices and make that sharing of the streams and content extremely, extremely simple. So with this, I want to be cautious of the time. I know that we want to leave some space for questions. So with that, I'm going to, let me stop my share. And there we go. And there it is. Barry, I'm...
Okay, well, thank you for that.
Back to you.
Yep, thank you so much. So I'm going to go back to our key slide here, and then I'm going to go take a look at the questions, because we've had a lot of really great questions come through. And thank you for leaving time, and thank you for really talking about the scale of the implementation of NDI. I had no idea there was thousands and thousands of streams that are happening simultaneously. So we'll just start at the top of the questions. There's a lot of great questions, as I said, that came through. This is a question for Will. Can you talk about the bit depth in the NDI streams? There's a question about that came up about 10-bit versus 8-bit and color depth. And I know from finishing, there's banding. I know that you answered it in the chat, but just so we have we have it here. If you could just discuss the bit depth question.
Of course, it's a great question and one that's really really important. I think specifically like whether the higher color depths or things greater than 8-bit, is that limited to particular versions? There's a lot of context that go into this, but at the high level, we have the 3 different variations, of course, of NDI that all work in an interoperable way. And when you are attempting to take higher color computations across multiple platforms, especially into more of a fragmented environment of Linux and then FPGA work and all the various things you go there, there's a lot of complexity that comes to that. So many times we do have to do a down conversion. We have 16-bit full pipeline in Windows 64. However, depending on what the hardware and OS environments is, yes, we are currently limited in some cases to 8-bit transfers. Now, this is an area that we are, let me just say, we have active development working on right now, because this is a very important thing, especially if we're talking about cloud productions and sports, for instance. So I would say, stay tuned. I can't tell you any more than that right now, but stay tuned, because this is, it's a great question and something that we do look to address.
Thank you for that. Yeah, I'll definitely be keeping my eyes peeled for some interesting NAB announcements. We did talk about the difference between NDI and 2110 a number of times. Here's a quick one. Can the HX devices be upgraded to HX3 via firmware?
Yeah, I think that's, to me, again, really it does depend on hardware capabilities to be able to meet the HX3 compute requirements. Generally speaking, we probably aren't going to see a lot of devices that are in the market that will meet those. However, I won't say never, never is never, but generally speaking, it probably is going to include new or different hardware.
Here's a good one too about the type of switch that you use for NDI. Maybe Jorge, you can take this as a system integrator. What's your kind of base level of switch that you need for an NDI implementation?
Absolutely. So this is an important question, because in many cases, the messaging, especially in the beginning, is just plug it on the network and it's going to work. And yes, I mean, in essence, that's the case. But when you want to start utilizing NDI within a professional environment, definitely the type of switch that you want to use is ideally one that can sustain a full bandwidth on the backplane. So you know that there are, I mean, basic switches for home or business where they claim all the ports are 1 gig and so on and so forward. But when you look at the speed on the backplane, they cannot run at 1 gig bidirectional on all the ports. So those are things that when you are looking into setting up a professional production environment where NDI is going to be a part of, absolutely, I mean, a more enterprise class switch is going to be ideal. When I was talking this example of this facility running like literally thousands of NDI streams, they are not using business class switches. These are Arista switches, switches that are, I mean, top of the line, optimized to the latest bit in order to ensure traffic flow the way that is supposed to. So if you want to set up, let's say, a small production house where you're going to have a couple of cameras, a couple of editing systems, and you want to share and be able to monitor all the content, basically a full bandwidth backplane switch is going to be able to do it. And these are, I mean, fairly inexpensive. Netgear has a line actually that is specifically tuned to the Pro AV market, and those are switches in the range of, I mean, from $500 to something in the neighborhood of $1,200. So are fairly affordable. But if you are planning to do a more high-end infrastructure where a big number of streams are going to be part of that solution, definitely more enterprise switches are going to give you the tool set that you need and want to ensure that you do not run into any issues with the streams. No, and in an IP ecosystem, the switch is the lifeblood of your facility, no, as we all know.
Yeah, thank you for that. And just two other quick questions, and I'll see. I'll put Mike on the spot. So, can you talk about NDI and SRT, and how does NDI contrast with IPMX?
In the case of NDI and SRT, they are definitely.
Oh, Jorge, I asked for Mike to chime in.
Mike, I'm sorry.
No, Jorge, why don't you finish up SRT? I'll do IPMX.
Perfect.
No, for SRT, SRT is mainly a transport mechanism. No, where if I have to transport, a video from one place to another, SRT is a fantastic way to do it. Actually, NDI can be wrapped in SRT. Now, there are solutions, transport solutions, where is SRT transport with NDI wrap into. No, but in the case of NDI, let's remember that NDI, because of all the capabilities, is not just video and audio, but all the metadata. And on all that metadata, you can have PTC control, KVM, tally information is a much wider use end-to-end, what you're going to do with NDI as with SRT. SRT was primarily designed for as a transport mechanism with all the protection in order to ensure that you have a reliable connection between the two endpoints. Please, Mike.
Yeah, so IPMX is actually built upon SMPTE 2110. The intention for IPMX is to enable the technology that's been used in the development of 2110 to enter the more pro AV side of the market. So what IPMX has done is remove the absolute requirement for SMPTE 2059-2 locking between all senders and receivers. Of course, if PTP is available in the network, any sender or receiver needs to lock to it. But what you do end up losing there is that timing quality that you have with SMPTE 2110. Not that IPMX can't have good timing quality, but it's given up a little bit. And so that provides the capability to use cheaper network switches, which has been one of the greatest costs to infrastructure to implement SMPTE 2110. IPMX also IPMX supports uncompressed video, and it also supports compressed video. So the technology they chose to utilize is JPEG XS within IPMX. So it doesn't include a native control architecture as it does with NDI, but NMOS is going to be the control architecture around IPMX. So the video services form is we're still completing all of the structure around that, and we're getting close to being able to provide that as a specification to SMPTE.
Thank you, Mike, for that answer. So I wanted to thank everybody for joining today. For NDI, we can go to ndi.tv. For AJA, I know we can go to aja.com. And for ASG, what's your URL?
asgllc.com.
Perfect.
Yes.
So thanks everybody for joining us today on this brief journey through NDI. I've definitely learned a lot, and I hope that everyone else has as well. So thank you so much, and we'll see you at the next meeting. Just as a shout out for people in the LA area, we're gonna relaunch the pre-NAB meeting at the end of March. So we'll have a lively panel discussion at the Keycode Media office in Burbank. So I'll be looking forward to that. I'm looking forward to it too. It was a lot of fun in the past. And with that, I'll say goodbye to everyone, and thanks for joining today.
Thank you.
Thank you so much.
Thank
Bye.
you, Barry.